A very good morning to all of you. My name is Pooja Jain and I belongs to Swami Keshwan Institute of Technology Management in Gramuttan, Jaipur. In my previous lecture, I have covered the chemical admixtures part. Now we will proceed on mineral admixtures. In the last in the last audio lecture, we have covered that what is admixtures, the function of admixtures, types of chemical admixtures, and these details. Now the turn is for mineral admixtures. The mineral admixtures optimize the particle size distribution of the cementitious material that leads to homogeneous concrete. Basic meaning is that uh, because it has the it's a very fine size. As we all know, what are the mineral admixture? These are the fly ash, silica fume, rice husk, ground granulated blast furnace, slag, pozzolanic, cementitious, calcinite, clay, methaqualin, ये सभी बहुत माइक्रोफॉन्स टाइप में मिलते हैं या फिर हम with the help of the grinding mixtures uh, we turn their size in these small particle sizes and very small. It is less the size of the mineral admixture. Sometimes the size of the mineral admixtures are the less than the cement. So these are very microfines. With the help of these microfines, we change the particle size distribution curve of cementitious materials or binding materials, so it leads to homogeneous concrete. By this we increase the durability properties and all. In the further video we uh, learn which type of properties it increases. The basically we have to the basic we have considered three main aspects: social, environmental, and economic aspect for choosing the mineral admixtures. The mineral admixtures, the basic component of mineral admixtures are calcium oxide, aluminum oxide, and silica. Now, the properties of fly ash. The fine particulate waste material produced by pulverized coal based thermal power station is an environmental pollutant. It has a potential to a resource material. As per IS 3812 2003, the generic name of the waste product due to burning of coal or lignite in the boiler of a thermal power plant is pulverized fly ash. Pulverized fly ash can be fly ash, bottom ash, pond ash, or mound ash as per the process. Fly ash is the pulverized fuel ash extracted from the fuel gases by any suitable process like cyclone separation or electrostatic precipitations. Fly ash, also known as a pozzolan in PCC applications, are siliceous and aluminous material which in a finely divided form and in the presence of water react with calcium hydroxide at ordinary temperature to produce cementitious compounds. These are the environmental benefits by using fly ash. As we use fly ash in the concrete, it increases or it impacts the significant environmental benefits like increasing the life of concrete roads and structure by improving concrete durability. How the durability improve? Because it improves the particle size distribution curve, so we get the homogeneous concrete, and the pores in the concrete reduces, porosity reduces, that's why the durability increases. Net reduction in energy use and greenhouse gas and other adverse air emission when fly ash is used to replace or displace manufactured cement, because production of cement use 372 kilojoule per kg energy, but for the producing of fly ash it it use only net zero energy. So the fly ash not required any special type of energy, but for production the cement we have this amount 372 kilojoule per kg energy required. We have this much amount of energy required for production per kg, 372 kilojoule per kg. Reduction in amount of coal combustion products that must be disposed in landfills, and also conversion of other natural resources and materials. Benefit to concretes. In the fresh concrete, it improves the workability, decrease the water demand, and reduced heat of hydration. Because why it reduced the heat of hydration? Because we replaced cement, we replaced the cement by using fly ash. Just as a 10%, if we use 10% fly ash, then we use 90% cement as per to control concrete. So it reduced the heat of hydration and decrease the water demand and improve workability for the fresh concrete, in the fresh concrete. And for the hardened concretes, as it increase the ultimate strength, because it gives the later strength to concrete, reduce permeability, improve durability, improve resistance to corrosion, because it reduce the porosity. So the porosity is reduced, so the permeability is also reduced. Permeability is reduced, so the durability of the concrete is improved, because the other particles, other chemicals do not enter into the concrete, and it does not destroy the concrete, so the durability of the concrete increases. These are the specifications for fly ash and cement and concrete in this chart as per the ASTM European specification and IS 3812-2003. As per these codes, it is specified what is the component of SiO2 minimum. These are specified reactive soluble SiO2 minimum, and these Al2, MgO, LOI, total alkalis, SO3, all these charts are given in this slide. These are all the datas. Now the GGBFS, ground granulated blast furnace slag in concrete and its advantages. What is ground granulated blast furnace slag? It is a byproduct of iron manufacturing which, when added to concrete, improve its properties such as workability, strength and durability. GGBS हम लोग अप टू 60 to 70% तक रिप्लेस करते हैं सीमेंट को, because it has its own cementitious properties. In the presence of water, it shows cementitious properties alone. It is obtained by the heating of iron ore, limestone and coke at a temperature of about 1500 degrees Celsius. The main constituent of blast furnace slag is CaO, SiO2, Al2O3 and MgO. Basic three components are there always. These are the minerals that are found in most of the cementitious substances. What is the formation of granulated ground blast furnace slag? The formation of GGBFS is not direct. It is the byproduct of iron manufacturing as a molten slag and the molten iron. The byproduct of iron manufacturing as a molten slag and molten iron means जो हमारी आयरन मैन्युफैक्चरिंग यूनिट्स होती हैं उनका जो बाय प्रोडक्ट होता है दैट इज ओनली अ मोल्टन स्लैग एंड मोल्टन आयरन, नॉट अ GGBFS. GGBFS is not a byproduct of iron manufacturing. Byproduct of iron manufacturing is molten slag and molten iron. The molten slag consists of alumina and silica, also with a certain amount of oxides. This slag is later granulated by cooling it. For this, it is allowed to pass through a high pressure water jet This results in quenching of the particles, which results in granules of size lesser than 5 mm in diameter. The particles are further dried and ground in a rotating ball mill to form a fine powder known as ground granulated blast furnace slag cement. Ground granulated blast furnace slag cement. Now, different method can be employed to perform the main process called as the quenching. Based on what based on what method is employed, it can be known as pelletized slag, foamed or expanded slag, GGBFS, or air cooled blast furnace slag. The advantages of GGBFS in concrete. GGBFS in concrete increase the strength and durability of the concrete structure as compared to the control concrete. Sometimes as per the strength point of view, it gives the later strength to the concrete as per the specified by the journals. It reduces voids in concrete, hence reducing the permeability. GGBS gives a workable mix. It possesses good pumpable and compaction characteristics. The structure made of GGBFS constituent help in increasing sulfate attack resistance. The penetration of chloride can be decreased. The heat of hydration is less compared to conventional mixed hydration. The alkali silica reaction is resisted highly. These make the concrete more chemically stable, gives good surface finish and improves aesthetics. The color is more even and light compared to the controlled concrete. Basically, lower chances of efflorescence, the maintenance and repair cost of the structure are reduced, thus increasing the life cycle of concrete structure. Unlike cement, GGBFS does not produce carbon dioxide, sulfur dioxide, or nitrogen oxides. These are the basic advantages of GGBFS. These are the basic properties which gives when GGBFS is present in the concrete. The bleeding characteristics of fresh concrete with GGBFS. A higher replacement with GGBFS leads to increase in the bleeding. तो बेसिक है कि इससे ब्लीडिंग इंक्रीज होती है, तो हमें इसका बेहद हमें इसका मतलब एज पर इन दी स्टडीज़ हमें ये बहुत कंसीडर करना है कि इससे ब्लीडिंग इंक्रीज ना हो, क्योंकि अप टू दी हायर रिप्लेसमेंट लाइक 60 to 70% रिप्लेसमेंट जब हम सीमेंट का 50 to 70% तक रिप्लेस करते थे, क्योंकि ये हमें एज पर ओवर IS कोड्स हम GGBFS 60 to 70% तक रिप्लेस कर सकते हैं. हम इसे हाई स्ट्रेंथ कंक्रीट प्रोड्यूस करने के लिए यूज़ में लेते हैं. तो जब हम इसे रिप्लेस करते हैं तो वहाँ पर ब्लीडिंग नहीं होना चाहिए. ब्लीडिंग इज तो ब्लीडिंग प्रॉपर्टीज़, व्हाट इज़ द ब्लीडिंग प्रॉपर्टीज़? जब जो वाटर है वो इट इज़ द प्रॉपर्टीज़ ऑफ द फ्रेश कंक्रीट. और ब्लीडिंग बेसिकली क्या है कि जब हम उसे कॉम्पैक्ट करते हैं तो जैसे जो अर्ली आवर्स होते हैं उस टाइम पे जो वाटर है वो उसका जो लेवल है वो अप आ जाता है, और जो हमारा बाकी कंक्रीट मिक्स है वो डाउन हो जाता है. तो ऊपर वाटर आ जाता है. जो वाटर आ जाता है वो ड्यू टू द एनवायरमेंट एंड कंडीशंस वो एवोपरेट हो जाता है. तो उससे क्या होता है कि हमारा वाटर कंटेंट कम हो जाता है. पर्टिकुलर वाटर सीमेंट रेशो, वाटर बाइंडर रेशो कम हो गया, तो उसके इफ़ेक्ट्स हमें आगे देखना होता है. तो हमें इसका ब्लीडिंग करेक्टरिस्टिक्स को बहुत मेजरली कैलकुलेट करना है और इसके ऊपर अच्छे से वर्क करना है. वर्केबिलिटी करेक्टरिस्टिक्स ऑफ कंक्रीट विद GGBS. द रीज़न फॉर द हायर वर्केबिलिटी is due to the spherical and glass textures of particle surface, because जो GGBFS है उसका जो texture होता है वो spherical होता है and it's a glass texture. तो जब ये spherical surface and glass है तो obviously इसकी properties workability properties को increase कर देता है. Glass count of GGBFS. It is potentially reactive in nature, hence greater the proportion of glass, greater is the rate of reaction. It is recommended to have a glass count greater than 67%. Stiffening times. The GGBF stiffening times means जब आपकी कंक्रीट है वो किस टाइम पे स्टिफन हो जाती है, मतलब वो अपनी स्ट्रेंथ गेन कर लेती है. तो द GGBFS इज स्लोअर इन रिएक्शन with the water compared with the Portland cement. So it gives the it reduce the initial it increase the initial setting time, and it initial setting time, and it or it increase the it also increase the final setting time. तो यह हमारा जो कंक्रीट है वो हार्ड पर्टिकुलर टाइम से लेट होता है. जो हमारे, अगर हम इसे कंट्रोल कंक्रीट से कंपेयर करें तो इसका जो स्टिफनिंग टाइम है वो इंक्रीज हो जाता है, बिकॉज जो रिएक्शन रेट है वो डिक्रीज हो जाती है. नाउ बेसिकली वो रिएक्शंस क्या हैं जिसके ऊपर ये डिपेंड करता है. तो द केमिकल रिएक्शंस ऑफ GGBS एज पर इन आवर OPC ऑर्डिनरी पोर्टलैंड सीमेंट कंक्रीट, जो हमारा है नॉर्मल कंट्रोल कंक्रीट है, जिसमें हम सिर्फ सीमेंट यूज़ में ले रहे हैं और अदर कुछ यूज़ में नहीं ले रहे. तो जो सीमेंट है वो वाटर से रिएक्ट करके बेसिकली जो हमारा मेन कंपोनेंट है जो हमें हार्डनिंग प्रोवाइड करता है, दैट इज़ ओवर CSS जेल. तो वो CSH जेल बनाता है विद और इसके साथ में वो कुछ एल्कली प्रोडक्ट्स बनाता है, दैट इज़ कैल्शियम हाइड्रोक्साइड, सोडियम हाइड्रोक्साइड और पोटेशियम हाइड्रोक्साइड. जो बेसिक एल्कली कंपाउंड्स हैं, यही आगे GGBFS के ऊपर इसको रिएक्शन कराने में वाटर से एप्लीकेबल है. तो ये जो मेन कंपोनेंट्स हैं एल्कली, जो ये एल्कली हैं, जो एल्कली बाय प्रोडक्ट्स हैं उस OPC प्लस वाटर के, तो ये जो हमारे पास ये जो एल्कली कंपाउंड्स हैं, एल्कली कंपाउंड्स जो बने हैं, इससे बेसिक क्या होता है कि हमारा जो कंक्रीट मिक्सचर है उसका pH लेवल हाई हो जाता है, और जो GGBFS है इसे एक हाई pH लेवल, जब जितना pH लेवल हाई होगा उस पर ये हाईली रिएक्टिव होता है. तो इसे उसका कंक्रीट मिक्स का pH लेवल इंक्रीज कर देता है, और बेसिकली टेम्परेचर भी इंक्रीज करता है. क्योंकि बेसिकली जब OPC है वो वाटर से रिएक्ट करेगी तो इट इज़ द एक्सोथर्मिक प्रोसेस. तो वहाँ पर हीट जनरेट होती है विद द हेल्प ऑफ दैट हीट, एंड दीज एल्कली कंपाउंड्स ये आपस में वर्क करते हैं, GGBS वाटर एंड दीज एल्कली कंपाउंड्स, और ये हमारे पास एक अलग डिफरेंट टाइप का CSH जेल बनाता है जिसमें पोटेशियम और सोडियम भी एग्जिस्ट करते हैं. तो दीज आर द बेसिक रिएक्शंस व्हेन we use GGBFS in our control mix. The rate of reaction undergone in a concrete mix with GGBFS mainly depends upon the following factor. जैसा हमने ऊपर भी देखा, तो बेसिक है टेम्परेचर. with increase in temperature the reaction rate increases and vice versa. The quantity of the components, the increase in the cement component proportion will increase the reaction, because GGBFS को रिएक्शन करने के लिए जो एल्कली कंपाउंड्स की रिक्वायरमेंट है वो हमें कहाँ से मिल रहे हैं, विद द हेल्प ऑफ दैट सीमेंट रिएक्शन विद द हेल्प ऑफ द हाइड्रेशन ऑफ सीमेंट. तो जो हाइड्रेशन ऑफ सीमेंट जब होगा तो हमें वो एल्कली कंपाउंड्स मिलेंगे, और जो एल्कली कंपाउंड्स मिलेंगे वो हमारे GGBFS को CSH जेल में कन्वर्ट कर लेंगे, और जो CSH जेल बनेगा वो हमें हार्डनिंग प्रोवाइड करेगा. द प्रॉपर्टीज, द केमिकल कंपोजिशन and the fineness of the component have an influence of the rate of reaction. ये हमें सब पता है कि जितना मटेरियल फाइन होगा उतना ही ज़्यादा उसकी रेट ऑफ रिएक्शन होगी. बेसिक, क्योंकि OPC 33, OPC 43 एंड OPC 53 में एज अ कंपोनेंट कोई चेंजेस नहीं है. बेसिक चेंज क्या, उसके फाइनेस, जितना ज़्यादा सीमेंट फाइन होगा उतनी ज़्यादा उसकी ग्रेड होगी, उतनी ज़्यादा वो हमारा सबसे ज़्यादा फाइनेस जो हमारा सीमेंट है इन दी OPC, दैट इज OPC 53. Now GGBFS is completed. We have to switch over. Our topic is highly reactive metacovalent concrete. It is produced from high purity kaolin clay by calcination at temperature ranging from 700 to 800 degrees centigrade. Highly reactive metacovalent concrete. It's basically effects on the strength development of concrete, drying shrinkage of concrete, and durability of hardened concrete. Strength development of concrete, it achieves greater strength than the control concrete because it is highly reactive. As the name shows, it's highly reactive metakaolin. It increased the strength development of the concrete, and it lowered the drying shrinkage problem in the concrete. When we use highly reactive metakaolin in the control concrete, it reduces the drying shrinkage. As per the generals or previous studies, durability of hardened concrete. Metakaolin in concrete tend to reduce the size of pores, which consequently lead to obtain more strength, higher density, and more resistance to acid attacks. Application of concrete containing metakaolin. It improves the strength of lightweight concrete, decrease permeability, and releasing post tensioning earlier. Develop flexor strength early, increase both reflectivity and durability factor, increase the strength and tackle alkali silica reaction, enhance क्लोराइड रेजिस्टेंस, इंक्रीज परमेबिलिटी, ड्यूरेबिलिटी एंड स्ट्रेंथ. बेसिक है कि ये परमेबिलिटी, ड्यूरेबिलिटी और उसकी स्ट्रेंथ बेसिकली क्यों इंक्रीज कर रहा है, क्योंकि बिकॉज दिस इज ऑल्सो माइक्रोफाइन्स, और ये हमारी पार्टिकल साइज डिस्ट्रीब्यूशन को भी करता है. होमोजीनियस कॉन्क्रीट प्रोवाइड होती है, पोरोसिटी रिड्यूस हो जाती है. पोरोसिटी रिड्यूस हो रही है तो बेसिकली ये सब चीज़ें इसके ऊपर डिपेंड करती है. और durability. Now what is the now we switch the topic on microsilica in concrete. What is microsilica? Microsilica, also known as silica fume or condensed silica fume, is a mineral admixture composed of very fine solid glassy spheres of silicon dioxide. It is usually found as a byproduct in the industrial manufacture of ferrosilicon and metallic silicon in high temperature electric arc furnaces. Microsilica reduces the rate of carbonation and decrease permeability to chloride. As a result, microsilica concrete is able to strongly protect reinforcement and embedment from aggressive agents. It is available in three forms: powder microsilica, condensed microsilica, and slurry microsilica. Effect of microsilica on concrete. Effect on fresh concrete: it reduces segregation possibility, so it can be used as a pumping aid. It almost eliminate bleeding, consequently finishing work shall begin early. Workability and consistency of concrete decreases. बेसिकली फ्रेश कंक्रीट ये सेग्रीगेशन की जो पॉसिबिलिटी है उसको रिड्यूस करता है. तो ऐसे जैसे शॉर्टक्रीट होती हैं और शॉर्टक्रीट टाइप की पंपिंग्स कंक्रीटिंग हैं और अदर कंक्रीट्स हैं, उसमें हम इसको यूज़ करते हैं माइक्रोसिलिका का. बेसिकली उसकी सेग्रीगेशन, ब्लीडिंग सेग्रीगेशन की प्रॉब्लम्स को रिड्यूस कर देता है. और जो इनका इफेक्ट है फॉर द हार्डन कंक्रीट, ऑन द हार्डन कंक्रीट इसका जो इफेक्ट है दैट इज द कंप्रेसिव स्ट्रेंथ. Hence flexure and tensile strengths are improved as well. इसकी बॉन्ड स्ट्रेंथ को भी इंक्रीज करता है. अब्रेशन रेजिस्टेंस, रिड्यूस परमेबिलिटी, therefore it helps in protecting reinforcement steel from corrosion, impact and cavitation resistance, sulfate resistance, heat reduction, chemical resistance. ये सारे के सारे इसके इफेक्ट्स हैं ऑन फ्रेश कॉन्क्रीट एंड हार्डन कॉन्क्रीट्स के. What are the properties of microsilica? The microsilica is a gray, nearly white to nearly black powder. Spherical particles less than 1 millimeter in diameter. 1 millimeter in diameter, very less. The bulk density of microsilica is based on the degree of densification and varies from 130 to 600 kg per meter cube. The specific gravity of microsilica ranges between 2.2 to 2.3. The practical use of microsilica, basically it is as per their properties, as per their effects. It uses in silica fume waterproof concrete. By use this microsilica we produce high strength concrete. It's uses in shotcrete, elastomers, polymers, refractories, ceramic and rubber application. In some इनका uses है. Now the advantages of microsilica. It reduces the thermal cracking caused by the heat of cement hydration, improve durability to attack by sulfate and acid waters, reduce the early age temperature rise. Silica fume is cheap, therefore it is cost effective. It reduces the overall slab weight and cost. Addition of microsilica decreases efflorescence due to the refined pore structure and increased consumption of the calcium hydroxide. Thank you. Basically इसमें एज पर आवर जो RTU सिलेबस है उसके अकॉर्डिंग हमने इसको कवर किया है. सारे टॉपिक्स ऑलमोस्ट हमने इसमें कवर कर लिए हैं. इन फ्यूचर आपको स्टूडेंट्स जो भी रिगार्डिंग इससे प्रॉब्लम्स है आप मुझसे कांटेक्ट कर सकते हैं. थैंक यू.